A short answer type question. Here, each question carries a 2 marks. The first question is define the terms a standard enthalpy of combustion and enthalpy of sublimation. That is, each definition carries a single mark. That is, two definitions are asked for 2 marks, and hence one definition has 1 mark. That is the first definition, a standard enthalpy of a combustion. It can be defined as the standard enthalpy of combustion of substance is the enthalpy change when or a reaction in which 1 mole of substance in its a standard state is completely oxidized. The standard enthalpy of combustion can be defined as the enthalpy change uh, taking place in the reaction where 1 mole of substance in its a standard state is completely burned or completely oxidized is called as a standard enthalpy of a combustion. Our definition must include a complete oxidation or complete burning of 1 mole of a standard substance. This 1 mole of standard substance and burning are the important words in this definition. Then a second definition, enthalpy of sublimation. We all know that a sublimation means the process in which solids are directly converted into a gaseous states, and hence the enthalpy change for the conversion of 1 mole of solid directly into the vapor at constant temperature and a pressure is known as a enthalpy of a sublimation. Enthalpy of sublimation means the enthalpy change for the conversion of 1 mole of a solid substance into vapors at constant temperature and constant pressure is known as enthalpy of sublimation. Two definitions are asked, but each definition carries a single marks. Okay. The next question, short answer type question. State and explain Hesse's law of constant heat summation. State and explain Hesse's law of constant heat summation. This is very important question asked for a many times in a board examination. Hesse's law of constant heat summation can be stated as overall enthalpy change for the reaction is equal to overall enthalpy change for the reaction is equal to sum of enthalpy change of individual steps in the reaction. That is, the sum of enthalpies of individual steps in the reaction is equal to overall enthalpy change for the reaction. That is, enthalpy change does not depend upon a path followed by system. It depends only and only upon initial states and final states. For example, explanation. The enthalpy change for chemical reaction is the same regardless of the path by which the reaction occurs. That is, this Hesse's law cannot consider the path, mechanism or way by which system changes from one state to another state. To determine the overall equation of a reaction, reactant products in the individual steps are added or subtracted like the algebraic step. That is when the reaction takes place in more than one steps. Then addition of all these steps gives our final required equation. For example, here consider a synthesis or formation of ammoniac gas. This reaction takes place in two different steps. In step number 1, hydrogen reacts with nitrogen to form N2H4, that is twice H2 gas. plus N2 gas gives N2H4 gas. The enthalpy of reaction delta RH1 is equal to plus 95.4 kilojoules. In second step, this product N2H4 again reacts with hydrogen gas, and for 2 moles of ammonia, the enthalpy of reaction is equal to minus 187.6 kilojoules per mole. After addition, the final reaction is thrice hydrogen gas plus nitrogen gas gives twice ammonia gas, and the enthalpy of reaction is equal to minus 92.2 kilojoules. That is the sum of enthalpy changes of both steps gives overall enthalpy change for the reaction. Once again, Assay's law can be stated as the overall enthalpy change for reaction is always equal to a sum of enthalpy changes of the individual steps of the reaction. Here, a correct statement carries 1 mark, and explanation with example carries 1 mark. That is, this question carries 2 marks. The next question, write the futures of reversible reaction. A reversible reaction means the reaction which takes place in both direction, forward as well as a backward direction. Okay. Following are important features of reversible process. In reversible process, the driving force and opposing force differ by infinitesimally small amount. That is rate of forward reaction and rate of backward reaction, or the driving force and opposing force differs by infinitesimally small amount. The process can be reversed by an infinitesimally change in a condition. If we increases the driving force, then a reaction becomes takes place in forward direction. If we increases infinitesimally the opposing force, the reaction will take place in a backward direction. Hence, the process can be reversed by infinitesimally small change in a condition. Then next feature, a reversible process proceeds infinitesimally small. That is, the reversible process is a slow process, and it takes place infinite number to complete. That is, reversible process are slow processes. It contains a number of infinitesimally small steps. And last feature, all at the end of every step, at the end of every step, the system attains a mechanical equilibrium with the surrounding. This is very, very important features of reversible process. That is, at the end of every steps, the process must attain the mechanical equilibrium with the surrounding. These are the 4 important features of a reversible process. Each features carries half marks. The next question, a derivation. Derive the expression or derive the expression for a pressure volume work. A pressure volume work is also known as a mechanical work done. To derive this equation, see, here is a diagram. We have to consider a certain amount of gas is enclosed in a cylinder. The gas is enclosed in a cylinder. The cylinder is fitted with weightless and frictionless pistons. P is the pressure of a gas. Okay. Here, V1 is its initial volume and V2 is the final volume. That is after the expansion of a gas. On expansion, this piston moves in upward direction. So this distance, a small d. We all know that a force is given by an equation, external pressure multiplied by a distance. That is, F is equal to minus P external into displacement capital A. If a piston moves a distance d, then amount of work done is equal to a force multiplied by a distance. That is, work is equal to a product of force and displacement, and hence W is equal to F into D. But we know that force is given by equation minus P external into A. After putting these values, the equation will become like that. W is equal to minus P external into capital A, that is cross sectional area, into a displacement. A into displacement is equal to change in volume. A into D is nothing but a cross sectional area multiplied by this displacement gives the change in volume, and hence this equation number 2 becomes W is equal to minus P external into delta P, change in volume, that is V2 minus V1. This is our required derivation. See here, this derivation carries 2 marks. Okay, half mark is for your consideration and diagram, then half marks for this equation for force, half marks for work done W, and half mark for this final equation. Hence, such equation carries 2 marks. Okay, next question. The enthalpy change of following reaction. एक प्रॉब्लेम दिलाय आपल्याला, एक रिएक्शन दिली, मिथेन गॅस प्लस क्लोरीन गॅस, CH4 gas plus Cl2 gas gives CH3Cl gas plus HCl gas. Delta H0 enthalpy of reaction is equal to minus 104 kilojoules. We have to calculate carbon dash chlorine bond enthalpy. The given bond enthalpies are carbon hydrogen bond enthalpy is equal to 114 kilojoules per mole. Chlorine bond enthalpy 243. Hydrogen and chlorine bond enthalpy is equal to 431 kilojoules per mole. Okay. तो प्रॉब्लेम एकदा नीट वाचल्यानंतर ज्या व्हॅल्यू दिल्यात त्या व्हॅल्यू आपण इथे व्यवस्थित मेन्शन केल्यात, ज्या चार्ट मध्ये दिल्या होत्या आपल्याला टेब्युलर फॉर्म मध्ये. मग फर्स्ट ऑफ ऑल construct the required equation. आपल्याला दिले ते इक्वेशन की CH4 गॅस प्लस Cl2 गॅस. आपल्याला फॉर्म्युला माहिती आहे, जर बॉन्ड एंथॅल्पी दिली असेल, आपल्याला एंथॅल्पी ऑफ रिएक्शन कॅल्क्युलेट करायचे असेल तर काय फॉर्म्युला आहे आपल्याकडे? एंथॅल्पी ऑफ रिएक्शन इज इक्वल टू बॉन्ड एंथॅल्पीज ऑफ रिएक्टंट मायनस अ समेशन ऑफ bond enthalpies of product. That is total bond enthalpy of reactants minus total bond enthalpies of products gives our enthalpy of reaction. मग इथे किती किती बॉन्ड आहे ते आपल्याला कन्सिडर करावं लागेल. आपल्याला पहिला रिएक्टंट बघा CH4, that is there are 4 carbon hydrogen bonds and hence 4 into delta CH. Okay. A second reactant is chlorine, that is there is only one bond between chlorine and chlorine, delta H, chlorine dash chlorine, minus product जर तुम्ही बघितलं CH3Cl, that is there are 3 carbon hydrogen, 3 delta CH plus 1 carbon chlorine CCl dash plus HCl मध्ये delta H and Cl. Okay, after doing the complete calculation, delta H0 CH plus delta H0 CH सगळं कॅल्क्युलेशन केल्यानंतर हे -400 -104 these are the values of total enthalpy change. आणि आपल्याला काय कॅल्क्युलेट करायचंय? कार्बन डॅश क्लोरीन. त्या सगळ्या स्टेप जर तुम्ही व्यवस्थित फॉलो केल्या, या व्हॅल्यू तुम्ही पुटअप केल्या, तर अगदी न चुकता अशा प्रॉब्लेम्सला 2 मार्क्स आपल्याला हमखास मिळू शकतात. इट्स आर द सिंपल प्रॉब्लेम्स. कुठलंही कॅल्क्युलेशन हार्ड नाहीये, फक्त प्रॉब्लेम व्यवस्थित वाचायचा आहे. आणि आपल्याला सगळ्यात महत्त्वाचं काय की रिएक्टंट्स, प्रॉडक्ट्स त्यामध्ये नंबर ऑफ बॉन्ड्स किती येतात हे जर पटकन समजत नसेल तर स्ट्रक्चर ड्रॉ करायचं. कार्बन डॅश हायड्रोजन 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 म्हणजे आपल्या लक्षात येतं की देर आर 4 कार्बन अँड हायड्रोजन बॉन्ड्स. CH3Cl तुम्ही स्ट्रक्चर जर काढला कार्बन हायड्रोजन 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 क्लोरीन देर आर 3 कार्बन हायड्रोजन अँड 1 कार्बन डॅश क्लोरीन बॉन्ड. व्हॅल्यू पुटअप केलंय कॅल्क्युलेशन केलंय की फायनल आन्सर आपल्याला इझिली मिळू शकते. 6 नंबरचं क्वेश्चन शॉर्ट आन्सर क्वेश्चन फॉर 2 मार्क्स. कॅल्क्युलेट द स्टँडर्ड एन्थॅल्पी ऑफ कंबशन ऑफ CH4. मिथेनची आपल्याला एन्थॅल्पी कॅल्क्युलेट करायची त्यासाठी आपल्याला दिले बघा इफ enthalpy for formation of CH4 is equal to minus 74.8 kilojoules. तसंच कार्बन डायऑक्साइडची एन्थॅल्पी ऑफ फॉर्मेशन आपल्याला दिली minus 393.5 kilojoules per mole आणि वॉटरची सुद्धा आपल्याला व्हॅल्यू दिली minus 285.8 kilojoules per mole. जो डाटा दिला होता तो व्यवस्थित परत एकदा आपण लिहून घेतलाय. मग नेहमीप्रमाणे टू फाइंड द एन्थॅल्पी ऑफ कंबशन आपल्याला एन्थॅल्पी ऑफ कंबशन फाइंड आउट करायचे. मग सगळ्यात अगोदर त्यासाठी आपल्याला रिक्वायर्ड इक्वेशन कन्स्ट्रक्ट करावं लागेल की कंबशन इज नथिंग बट आत्ताच आपण डेफिनेशन बघितली एन्थॅल्पी ऑफ कंबशनची. कंबशन म्हणजे काय? अ स्टँडर्ड सबस्टन्स इज बर्न or reacted with excess of oxygen, and when carbohydrates are burned undergo combustion they will always use carbon dioxide and water as a product. म्हणून आपल्याला मी त्यांचा फॉर्म्युला माहिती आहे CH4 gas plus twice O2 gas. our product is CO2 gas plus twice H2 gas. नेहमीप्रमाणे डेल्टा RH किंवा एन्थॅल्पी ऑफ रिएक्शन इज इक्वल टू आपल्याला फॉर्म्युला माहिती आहे एन्थॅल्पीज ऑफ प्रॉडक्ट्स मायनस एन्थॅल्पीज ऑफ रिएक्टंट. ओके मग प्रॉडक्ट्स मध्ये आपल्याला CO2 ची व्हॅल्यू दिलेली ती व्हॅल्यू पुटअप करा. इथे व्हॅल्यू दिली -393.5. त्यानंतर सेकंड रिएक्टंट आपल्याला ट्वाइस O2 गॅस. मग ट्वाइस O2 ऑक्सिजनची तुम्हाला जी व्हॅल्यू दिली असेल ती व्हॅल्यू व्यवस्थित पुटअप करायची आणि मग फायनल इक्वेशन तुम्हाला बरोबर मिळून जाईल. काय मिळते ते बघा. व्हॅल्यू पुटअप केलं की फायनल आन्सर आपल्याला मिळते -890.3 kilojoules per mole. ह्या पॅटर्न वरचा किंवा आत्ताच आपण सोडवलेला एक प्रॉब्लेम 100% प्रॉब्लेम 2 मार्काला विचारले जाऊ शकते. ओके नेक्स्ट क्वेश्चन. डिफाइन अन आयसोलेटेड सिस्टीम. त्यालाच आणखीन प्रॉब्लेम विचारला 3 moles of an ideal gas. Isolated system means a system which does not allow the exchange of energy as well as matter with surrounding. A system which cannot exchange, which does not allow the exchange of either energy or matter with the surrounding is called as an isolated. The system is completely isolated from the surrounding. There is no exchange of energy as well as matter are possible from system to surrounding. Okay, very simple definition which carries a single mark. Then 2 marks are given for this problem. This is the short answer question type 3 which carries 3 marks. Okay. गिवन काय काय दिले आपल्याला 3 moles of an ideal gas that is N is equal to 3 expands isothermally V1 15 decimeter cube V2 20 decimeter cube. प्रेशरची व्हॅल्यू सुद्धा आपल्याला दिली की एक्सटर्नल प्रेशर इज इक्वल टू 1.2 बार. प्रॉब्लेम एकदा नीट वाचायचा आहे. प्रॉब्लेम पहिल्यांदा वाचला की डाटा आपल्याला काय काय दिलाय ते आपल्याला व्यवस्थित येत आहे. एक्सपान्शन झाले त्याचं 15 to 20 decimeter cube. Hence 15 is initial volume, 20 is our final value. External pressure is equal to 1.2 bar. आणि आपल्याला काय विचारलं त्यांनी अमाऊंट ऑफ वर्क इन joules. मग फॉर्म्युला आता आपण जो बघितलाय मेकॅनिकल वर्क डन साठीचा W is equal to minus P external into delta V change in volume that is V2 minus V1. एकदा फॉर्म्युला व्यवस्थित लिहिलं की नेक्स्ट स्टेप मध्ये सगळ्या व्हॅल्यू व्यवस्थित आपल्याला पुटअप करायचे तिथे. व्हॅल्यू टाका P एक्सटर्नल 1.2 V2 20 minus 15, that is delta V is equal to 5 decimeter cube. 1.2 into 5, which is equal to minus 6 decimeter cube bar. आपल्याला आन्सर मिळालाय डेसिमीटर क्यूब बार मध्ये. आपल्याला कशामध्ये कन्वर्ट करायचं ते जूल्स मध्ये कन्वर्ट करायचे. आपल्याला 2 नंबरचं एमसीक्यू सुद्धा या प्रकारचं विचारलं गेलं होतं. 1 डेसिमीटर बार इज नथिंग बट 100 जूल्स. याला 100 ने मल्टिप्लाय केलं की आन्सर आपल्याला मिळते द वर्क डन इज इक्वल टू minus 600 joules. ओके, दिलेले सगळे जे काही क्वेश्चन बँक मधले क्वेश्चन आहेत हे आपण सॉल्व्ह करतोय. सगळ्यात अगोदर ह्या चॅप्टरची सगळी क्वेश्चन व्यवस्थित करा. मॅक्झिमम प्रोबॅबिलिटी यावरती प्रश्न विचारले जाऊ शकतात. एकदा हे व्यवस्थित प्रिपेअर झाले की मग ऍडिशनल क्वेश्चन तुम्ही सॉल्व्ह करू शकता, पण अगोदर हे क्वेश्चन व्यवस्थित प्रिपेअर करू शकता. ओके, नाउ वी विल स्टॉप हियर. थँक यू व्हेरी मच.